Do you want to build a machine learning movie recommendation application for your portfolio, or just to show it off to your friends? It involves building and learning Python, NumPy, and Pandas. Let me walk you through the application. Cinematch. For example, let's search Spider-Man, and the AI model will predict for us similar movies that might be interesting to watch as well. Before we start, if you haven't already installed Visual Studio Code, you can download it from the official website and ensure that you have Python installed on your computer. You can download Python from the official website. Check the description for the website links. You can install Jupyter extension for Visual Studio Code by going to the extensions view by clicking on the square icon on the left sidebar, or pressing Ctrl+Shift+X or Command+Shift+X on Mac OS. In the search bar, type Jupyter. Click on the install button for Jupyter extension offered by Microsoft. Let's start with a brief introduction to Python. Create a new folder and name it Cinematch. Then create a file index.ipynb. This is going to activate the Jupyter notebook. Let's start with variables and data types. Think of variables as a box where you can store stuff. In programming, this stuff can be numbers, text, or more complex things. Let's see some examples. We create a variable number equals 10. Then we create another one, greeting equals hello world. Let's print these variables. Print number, print greeting. Now click on this button to see the variables printed. Let's create a new code block by clicking on this button here. Now let's talk about data types. The main types in Python are integers, floats, string, and booleans. Let's try some examples. Age equals 30 is an integer. Price equals 19.99 is a float. Name equals Bob is a string, and is_student equals true is a boolean. Now let's print the types of these variables. Print of type age, print of type price, print of type name, and print of type is student. When we click on this run button, it prints for us the data types of these variables. Let's create a new code block and move on to if statements and loops. An if statement is like a crossroad in your code. It lets your program take different paths based on a certain condition. Let me show you how it works. Let's create a variable age equals 20, and then we type if age is greater or equal to 18, we print you are an adult, else we print you are not an adult. In this example, the program checks if the age is 18 or more. If true, it prints you are an adult, otherwise you are not an adult. Now let's add more complexity with elif, which stands for else if. Let's create a variable time equals 13, and then if time is less than 12, we print good morning. Elif, which stands for else if, If 12 is less than time and time is less than 18, we print good afternoon. Else we print good evening. This lets your program print a greeting based on the time, and it's an example of more complex conditions. Let's talk about loops. Loops let you repeat actions. There are two main types in Python: for loops and while loops. A for loop runs a block of code a certain number of times. It's great for going through items in a list or range, or if the length of the items are known. Let's print an integers from 0 to 4. We type in for I in range of 5, we print I. Let's click on this run button. So we have 0, 1, 2, 3, and 4. It starts with 0 because in programming, indices are counted starting from 0. A while loop keeps running as long as a condition is true. If the condition never becomes false, the loop runs forever. Let's create an example. Count equals 1. Then we type while count is less than or equal to 4. We print loop iteration, then count. We increment the count by typing count plus or equal to 1. Let's press on the run button again. The loop runs 4 times as count starts from 1 and increase by 1 each time the loops run. Let's create a new code block and move on to functions and modules. Imagine a function as a mini program within your program. It's a block of code that you can call to perform a specific task. Let's see an example. We define a function greet, which accepts an argument of name, then returns hello plus the name. We can print a name by calling the function. So let's type print, then we call greet and pass in a name Alice. Let's hit on the run button and we have hello Alice. This function greet takes a name as an argument and returns greeting with a name. We can use it with different names and it will work the same way every time. Let's talk about why functions are so cool. Functions are reusable. You write once, use many times. They help in organizing our code by keeping them tidy and understandable. Let's move on to modules. Modules are like two bosses. They contain a set of functions and variables that you can use in your program. Python has a vast standard library of modules, and you can also create your own. Let's explore how to use a module. We import the math module. We can calculate the square root of a number using this math module. So we create a variable results equals math.sqrt, which stands for square root, and pass in the number we want to find the square root of. In this case, 16. When we type print results, we have 4.0 here. Alright, let's create a new code block and talk about lists, tuples, sets, and dictionaries. These are like different type of containers for your data. Each has its unique features. Let's first talk about lists. Let's create a list of fruits. Fruits equals apple, banana, and cherry. We can add item to the list using the append method. So we type fruits.append, then we type in the name of the item we want to append. In this case, let's type orange. We can also remove item from a list using the remove method. So fruits.remove banana. This is going to get rid of the banana inside this list. Let's print the fruits. So we have apple, cherry, and orange. Let's talk about tuples. Tuples are like lists, but you can't change them once created. Let's create a tuple. We create a variable, colors equals red, comma, green, and then blue. We can print the tuple and then hit on the run button. So we have it here. Let's move on to sets. Sets are unique. They can't have duplicates. It's like having a group where no two people can have the same name. Let's create a set, animals equals cat, dog, and fish. We can try and add a duplicate by typing animals.add cats and then print animals. Hit on the run button and we have cat, fish, and dog. Let's move on to dictionaries. Dictionary hold pairs of information, a key and a value. It's like a real dictionary where you have a word, the key, and its definition, the value. Let's create a dictionary. Person equals name, John. We have age 28. We can access the values in the dictionary by printing it out like print person, square brackets, and the name of the key. So let's print the name and then hit on this run button. So we have John here. We can add a new key value pair by typing person, square brackets, then the name of the key that we want to add. So let's add a hobby. Then equals the value we want to assign to this key. So let's type painting. So let's print person dictionary. And then we can see hobby was added. Let's create a new code block and talk about file handling. Reading a file involves opening it, reading its contents, and then closing it. Python makes this process straightforward. Let's read a test file as an example. Before, let's create a file and type in the following lines. New file, example.txt, and type in, this is a first line, this is a second line, and then this is a third line. Save it and then back to our code. We read a file by typing with open parentheses the name of the file. So in our case we type example.txt, then comma r as file. Then we create a variable content equals file.read. Then we can print content. In this example, with open parentheses example.txt, comma r opens the file in read mode because of the r. The with statement ensures the file is properly closed after each suit finishes, even if an error occurs. Then .read reads the entire content of the file. Let's click on the run button. And there we have it. Now, what if you only want to read the file line by line? We type with open, the name of the file, example.txt, comma r as file. Then we loop through the whole file. For line in file, we print line.strip. This way, you can process each line individually. which is particularly useful with large files. Writing to a file is as easy as reading from one. You can write text, data from user input, or even output from other parts of your program. Let's write to a file. We write to a file by typing with open parenthesis output.txt, which is the file name we want to write to, comma w as file. Then we type here file.write hello Python. Here open parenthesis output.txt, comma w opens a file name output.txt in a write mode. If the file doesn't exist, Python creates it. File.write is used to write text to the file. Running this is going to create a new file output.txt with the text hello world. Let's click on this run button, and there we have it. We have a new file output.txt. Let's click it and see what's inside. And then we have hello Python, which is the same as what we wrote to the file. Let's create a new code block and talk about working with CSV files. CSV stands for comma separated values. These files are simple text files with data separated by commas. They are often used for storing tabular data. Python CSV module makes reading and writing these files a breeze. We will use the Python CSV module to write and read from CSV files. Now let's create a new file, example.csv, and then type in this and save it. We first import the CSV module. Then we type with open parenthesis example.csv, comma r as file. Then we create a variable csv underscore reader equals csv.reader and pass in the file. We loop through the whole CSV file for row in CSV reader, and then we print the rows. In this example, we are using the csv.reader to read the CSV file line by line. Each row from the file is returned as a list. Let's hit on the run button, and there we have it. Let's create a new code block and talk about classes and objects. Let's start with the concept of a class. Think of a class as a blueprint or a template for creating objects. It defines the structure and behavior that object of the class will have. Imagine we have a class called car. This class can have attributes like color, make, model, and method like start and stop. Let's create our class. Then we define our constructor, which I am going to explain in a second. Div underscore init, and then we modify this one here, add the color, the make, and model. So we type self.color equals color, self.make equals make, self.model equals model. Oops, there is an error here, self. Then we define our functions. Define start of self, we print car started. Then we define a stop of self and print car stopped self. In this example, we define a car class with attributes color, make, and model, as well as method start and stop. Now that we have our car class, let's create objects from it. Objects are instances of a class. Let's create two instances. My car equals car, pass in a color of red, a make of Toyota, and the model of Camry. Then we create another instance. Your car equals car and pass in a color blue, a maker of Honda. Then we pass in the model of Civic. Here we've created two car objects, my car and your car, using the car class. Each object has its own set of attributes. To access the attribute method of an object, you use the dot notation. So let's print my car dot color and hit on the run button here. It gives us red. We can also call the method my car dot start, and then it prints for us car started. So this particular method here. In Python, the constructor method, denoted as init, is called when an object is created. It initializes the object's attributes. And this was a quick overview on Python. Let's explore NumPy. So we create a new folder, name NumPy, and create a new file, index.ipynb. In this section, we will explore NumPy, a powerful library for numerical computing in Python. By the end of this module, you understand what NumPy is, why it's important, and how to use it effectively. Let's start with NumPy array. NumPy provides a versatile array object called numpy.ndArray. It allows you to store and manipulate data efficiently. You can create arrays using NumPy in various ways. Let's begin by creating a one-dimensional array. So we import NumPy as np. Then we create a variable array underscore 1d np.array. Then we pass in a list of numbers 1, 2, 3, 4, and 5. Now let's move on to creating two-dimensional array, which is essentially a matrix. We create a matrix equals np.array and pass 1, 2, 3, comma, another list 4, 5, 6, then a final list 7, 8, 9. In this example, we created a 2D array matrix with 3 rows and 3 columns. Operation on arrays. NumPy makes it easy to perform element-wise operation on arrays, which means operations are applied to each element individually. Let's start with element-wise addition. We create a variable results underscore add equals array underscore 1d plus 10. Next, we have element-wise multiplication. So results underscore multiplication equals array underscore 1d multiply by 2. Here we multiply each element in array underscore yd by 2. NumPy also allows element-wise operation between arrays. So let's create two arrays. Array underscore a equals np.array, pass in a list of numbers 1, 2, and 3. Then array underscore b equals np.array, pass in 4, 5, and 6. We create a variable results underscore ops equals array a plus array b. In this example, we add array A and array B element-wise to create a results underscore oops. So let's go ahead and print results add, print results multiply, and print results ops. hit on the run button, and there we have it. Let's talk about NumPy functions. NumPy provides mathematical functions like sqrt and exp for square root and exponentiation. We create some few mathematical functions. Square root equals np.sqrt, pass in array underscore 1d, this particular array, and also create an exponential equals np.exp of array underscore 1d. In addition to mathematical functions, NumPy offers statistical functions like mean and std for calculating mean and standard deviation. So we create a mean value equals np.mean and pass in array underscore 1d, and also the standard deviation std equals np.std of array underscore 1d. NumPy allows broadcasting, which enables you to perform operations on arrays of different shapes efficiently. We create an example, array underscore broadcast equals np.array, pass 1, 2, 3, and then we create a scalar of 2. We create a variable results underscore broadcast equals array underscore broadcast multiply by the scalar. In this example, we multiplied array underscore broadcast by the scalar 2 using broadcasting. NumPy automatically applies the operation element-wise. Lastly, let's explore the random module in NumPy, which is essential for generating random numbers and arrays. You can generate random numbers from various probability distributions such as uniform, normal, and more. We create a variable random underscore uniform, which is np.random.uniform, passing 0, 1, 5. So this is going to give us 5 random numbers between 0 and 1. Then we have random underscore normal, which is equal to np.random.normal. We pass 0, 1, and 5. So it's going to generate for us random numbers from a standard normal distribution. You can also create random arrays with specific shape. For example, random underscore array equals np.random.rand. Then we pass in 3, 3. So this is going to create for us 3 by 3 array with random values between 0 and 1. You can go ahead and print all these variables and see the results. You've now explored NumPy arrays, NumPy functions, and random module in NumPy. To solidify your understanding, practice these concepts with rare datasets and explore more advanced features offered by NumPy. Let's create a new folder called Pandas and create a new file, index.ipnb. Let's start by understanding what Pandas is. Pandas is an open source library for data manipulation and analysis. It provides data structure like Pandas series and Pandas data frames, making it easier to work with structured data. Pandas introduces 2 primary data structures, Pandas series and Pandas data frame. Pandas series is similar to a one-dimensional array but with labeled data. Think of it as columns in a spreadsheet. We import pandas as pd. Then we create our first pandas series. Data equals pd.series parentheses. Then we pass in a list 10, 20, 30, 40, and 50. Pandas data frames, on the other hand, are two-dimensional structures resembling a table or spreadsheet. Let's create a Pandas data frame. df equals pd dot data frame, pass in a dict of name. We have Albert, we have John, then we pass age as well of 30 and 40. Here we create a data frame df with column name and age. Data frame indexing allows you to access and manipulate specific data within a data frame. So we create a variable name underscore column equals df square bracket, then we pass in the name. So we can print the name column by clicking on this button. Alright, let's create a new code block and then let's learn how to clean data in Pandas. So there is this file here, sample_data.csv. A link will be placed in the description to download this file. We will start by reading the CSV file. So we create a variable data equals pd.readCSV, then we pass in the name of the file, so sample_data.csv. So let's print the data and see what's inside. Let's click on this run button here, and there we have it. One common data cleaning task is filling in missing values, like what we have here. The price of Eve is missing, and then the height for Frank is also missing. So we type here data.fill na parenthesis 0, in place of true. So this in place true is going to apply the changes to the original data sets. When we pass in false, the changes is going to be applied to a copy of the original data set, but not the actual data. Let's cut this print statement and paste it here. So let's hit on the run button. So here we fill the missing values in the data frame with zeros. Another approach is dropping rows with missing values. So we comment this out and we type data.drop na in place of true, then hit on the run button. We remove rows with missing values using the drop na method. We can also remove duplicates in rows. Removing duplicate rows is crucial for ensuring clean data. We can do that by typing data.drop duplicates. Then we pass in place of true. So let's comment this out and then hit on run. All the duplicates were removed. Let's create a new code block and talk about data manipulation with Pandas. Pandas allows you to perform various data manipulation tasks. You can apply functions to data in a data frame. So let's type data square brackets discounted underscore price discounted underscore price equals data of square brackets, then type in price dot apply lambda of x multiply by 0.9. Here we apply a function to calculate a discounted price for the price column. You can also merge and concatenate data frames. So we create a variable merge_df, which is equal to pd.merge, which accepts in a data frame 1 and a data frame 2. Then we pass in on the key column. We can also concatenate using the concat method. Concatenated_df equals pd.concat and pass in data frame 1 and data frame 2. So these data frames could be any data frame of your choice. So you can create these data frames and then practice on your own. And that was a quick introduction to Pandas. Now we are about to create our movie recommendation system. In this project, we are going to build a full-stack machine learning application that recommends movie based on user preference. We will start with the model, then move to the front end and back-end components. Let's dive right in. First, let's organize our project. We create a new folder called Introductions. Then we copy everything into the Introductions folder. Inside our Cinematch folder, let's create 3 subfolders. First, the model, the front end, and the back end. Our model folder will contain the code responsible for recommending movies. Inside the model folder, we will create a Jupyter notebook named index.ipynb to build our recommendation model. In our model, we will work with a dataset of movies and their attributes. A link to download this dataset can be found in the description. We import NumPy as NP, then import Pandas as PD. Let's create a new code block and create a variable final_data equals pd.read_csv parenthesis, then the name of the dataset, movie_datasets.csv. Let's type final data.head and run all this code. When we run this code, it's going to give us the first 5 rows of the dataset. So we have the first 5 rows of the dataset. We've used Pandas to load the movie datasets into a data frame called final data. Now let's pre-process our data. We will focus on the tags column as it contains keywords describing the movies. Let's create a new code block, and then from sklearn.featureExtraction.text we import count vectorizer, then create a variable cv equals count vectorizer, pass in mass features of 6,000, then a stop words of English. This mass features 6,000 means we are limiting our model to focus on just 6,000 features. In this case, 6,000 tags, 6,000 different words inside the tags column. And stop words English is going to skip words like the, for, and it. Now let's convert the tags into numerical vectors. We create a variable vectors equals cv.fit_transform, pass in final data, select the tags column, then we convert it to array. We've used the count vectorizer to convert the tags column into a numerical vectors, making it suitable for our model. So we type vectors, then hit on the run button. Next, we perform word stemming to reduce words to their base form. Let's create a new code block, import NLTK, then from the NLTK library, we import the potter stemmer. Let's initialize the stemmer by typing ps equals potter stemmer. We define our stemming function as stemmer, which accepts an argument x. Then we create an empty list of stem words, an empty string. Then we do our loopings. Stem word dot append ps dot stem. Then we return string dot join of stem word. Now let's apply the stemming to the tags column. Final data of tags equals final underscore data. You have tags here, dot map lambda x of stemmer x. We've used the NLTK to perform word stemming on the task column, reducing variations and improving data consistency. In the stemming process, we are just flattening words of the same variation like run, running, and run into its basic form like run. Let's create a new code block and then type in cv dot get features name out parentheses, then run it. Alright, so this gives us the tags after it has done the stemming process. Now let's calculate the cosine similarity between movies based on their tags. From sklearn.metrics.pairwise, import cosine similarity. Then we create a variable similarity equals cosine similarity and pass in our vectors. We've used the cosine similarity to measure the similarity between movies based on their tag vectors. With our similarity matrix in place, let's create the function that recommends movies. Let's run the code and define our recommend movie function. Let's create a variable to store the movie index after a search has been found. Then we create a variable distances to store the cosine similarities. Then we create a variable to store in the recommended movie list. So now we loop through the recommended movie list, then print it out. Before we test that the recommendation function works, let's fix this error here. I think I made a typo with the similarity spellings. So let's type in similarity and then similarity. Alright, so let's create a new code block. Let's call our recommendation function recommend and pass in a movie name like Spider-Man. We've created a recommend function that finds movies similar to the ones you specify. When we call the function with Spider-Man, it suggests similar movies. To use this model in our backend, we will export the necessary data. So let's create a new code block, import pickle, then type in this code. So let's hit on run. We are using the pickle to export final_data and similarity matrix, which will be used in our backend to serve movie recommendations. Alright, so let's copy the files we just exported into the backend folder with the movie_data set as well. Now let's build the backend of our movie recommendation application using Flask. Make sure you have installed Flask and other required packages. Let's go through the code step by step. So we open our backend folder, then we click on server.py. A link to download this backend code will be placed in the description. We start by importing the necessary libraries: Flask for creating our web application, Flask calls to handle cross-origin requests, Pickle to load our pre-computed data, and Pandas for data manipulation. We create a Flask app and enable calls to allow requests from our front end running at localhost on port 3000. We load the movie datasets from movie_data.csv and normalize the movie title by stripping and converting them to lowercase. We load our pre-computed count vectorizer and similar matrix from similar.pkl. We define a route for the root URL, which will return a welcoming message. We create a recommend route that accepts a post request. This route will be used for recommending movies. We extract the movie name from the JSON data sent as the request. We attempt to find the index of the input movie title in our datasets. Then we calculate the similarity score between the input movie and all other movies. After sorting the movie by similar score, we select the top 5 recommended movies. We prepare the recommendation by extracting the movie title based on their indices. If the input movie title is not found, we handle gracefully by returning an error message. Finally, we run the Flask app in debug mode. To run the server, we open the terminal, we type Python, then server.py, hit enter, and our server is up and running. The front-end code is already available on GitHub, and you can find the link in the video description. Let's begin by understanding how we fetch movie recommendation from the backend. We open the front-end folder, navigate to App, Websites, then the home.js file. In this code, we define a function, fetch search results. This function sends a post request to the backend endpoint, passing the movie name as JSON data. We use the fetch API to make the requests. After we receive recommendations from the backend, we start by fetching movie details from an external API. In this case, the OMDB API. We use the fetch API again to request movie details for each recommended movies. Once we have all the movies details, we set movie detail state and update the loading state. You can get your own API key here by going to the official website for OMDB. Check the link in the description. Now that we have fetched our movie details, let's see how we display them. In this code, we use the map function to iterate over the movie details array. For each movie, we render a movie card component and pass in the movie details as a prop. In the use effect, we listen for the enter key. When the user press enter after entering a movie title in the search box, we call the fetch search results function to fetch the recommendations. And there you have it. You have seen how the front end of our movie recommendation application communicates with the back end to fetch movie recommendations, receive movie details, and display them using the movie card component. Now let's open our terminal and run the front end code by typing npm run dev. Now let's access localhost port 3000. Now let's try everything. Let's search for a movie, Spider-Man. We have a list of similar movies to Spider-Man based on our recommendation algorithm. But that's not all. We also have other details such as rating, upvote, language, and the year of release. The app also features a dark mode which you can toggle here. And we have these beautiful rendered recommendations. Thank you for joining us on this journey to build a movie recommendation application. If you've enjoyed this project and want to explore the code further, it's available on GitHub. Feel free to modify it to your liking and contribute to its developments. I encourage you to subscribe, like the video, and share your thoughts in the comments. It helps us create more exciting projects like this one. Cheers.